But the solid form solders are going to feed your machinery, I have a feeling, and take the boards through the process. Why don't you tell us about what's going on here?
Okay. Well, in a wave solder machine, we start the process out going through a fluxer to apply flux. Yep, we can go over here. So we apply flux to the bottom of the board. The flux's job is to prepare the copper on the barrels and leads, uh, remove oxides, so the solder will wet to the copper. So we start out by fluxing. Of course, we have a conveyor that'll convey the board through each one of our modules, starting with the fluxer module. Board gets fluxed, then it goes through preheat.
Now, let me pause just for a second. For fluxing, there's been a lot of coverage of fluxing. It's done in several ways and several forms. How is can you explain how the fluxing process happens here?
Okay.
Is it
Yes.
Are there vapor fluxes, and is there solid fluxes and liquid fluxes?
Well, we're using a liquid flux,
Okay.
and we're spraying it. So the most common method of getting it to the board in wave soldering today is spraying. So we're gonna spray. We spray the flux as the board's traveling. We traverse the spray nozzle perpendicular to the board travel,
Okay.
and it sprays as the board travels over it until the entire surface of the board is covered with flux. And then we also have to make sure when we spray it that the flux actually penetrates through the barrels to the top, so it covers all the copper surfaces. So then solder will wet from the bottom to the top.
Yeah, because copper oxidizes, and
Correct.
the idea is we have to deal with that, and the flux
Yes.
deals with that.
Yes. For solder to wet to the copper, we have to remove the oxides.
Yeah, let's move down. Can we move through here without disrupting?
So then we have to activate the flux to chemically activate it to get it to remove the oxides. So we do that with the preheat.
Well, hello. Thank you for joining us again. Kelly Dack for AltiumLive Connect 2022. And wow, what a day we've had on the show floor. I'm still amazed, still reeling from how fast they tear that show floor down and roll up the carpets and go. So I've been here with our cameraman, Michael, and he was kind enough to drive us over to Altium headquarters here in La Jolla, California. And we're here on a nice sunny day, just a beautiful view of the skyline here, the San Diego skyline. It's the other side of where we started, out on the bay, and the skyline down on the beautiful San Diego Bay. So just a wonderful experience, kind of old home week for me here. I used to live right down the street and made many good connections here down in the San Diego area. Wonderful businesses and companies here. Business seems to be booming, so we're very glad about that. I'm hoping that you've had a wonderful Altium Live experience so far throughout the day. I need to remind you that at what time is it now? Is it 4:15? We've had 4 more presentations start, so the day's not over. These should be very exciting, so please don't hesitate to go on into the other stages and pick a presentation and go with it. So very good. We have some things in store, some housekeeping here. I guess not housekeeping, but we like wrapping up the day. We like talking about all the wonderful things that we've gone through, all the things we've gone through together. And again, it's been a pleasure. How about the show floor? How about so many of the things we were able to the equipment we were able to see. I can't stop talking enough about how the inspection equipment that's on the show floor has changed and, to the point where it's able to recognize the micro features on these new circuits, the smaller, densely packed circuits. It's wonderful. We've got coming in pretty soon. We're expecting a call from Altium Tech Marketing Engineer Vince Mazer. So we're hanging out a little bit, waiting for Vince to come on the line, and we want to talk to him and review his talk today. So in the meantime, I'll talk to you some more, and I'm happy to, because this has been just. It seems like it's been such a supercharged last few days with our Altium content. There's Vince right now. Hi, Vince. Let me just finish up here our Altium content, and so much that's going on, and it's just a miracle effort that was put together here for the technology to come together so that we could bring you live on the show floor also, and we've really tried to combine the two events to the point where you feel like you're here. So hopefully you do. And I got to say, guaranteed live. We're live right now, and we have the pleasure to speak with Vince Mazer, technical marketing engineer, who gave a presentation today, and we thought it'd be a good idea, because some may not have seen it, to kind of fly back over it. Let's circle around and fly back, Vince, and you can tell us about the presentation and the high points, some of the points you hit, and full transparency, I didn't get to hear it, so I would love to hear about it, and maybe I'll have some questions for you too. So take it away.
Okay, well, it was entitled Avoiding Supply Chain Issues with Variance and Live BOM Part Choices. And variance and live BOM part choices are characteristics or capabilities that our products support. And basically, I started off with a review of electronic part supply chain fundamentals, talking about the difference between a manufacturer part number and a supplier part number. Talking about product discontinuation notices, product change notices, how you can sign up with those directly with your silicon vendors. We also talked about, just decomposing part numbers. I'm sure that was review for many people, but the idea of, that manufacturer part number and how it's made up of a lot of different codes, typically separated by dashes or not. We talked about the product life cycle definitions and referenced some research that was done on that and published in the IEEE. The life cycles being like pre-released, recommended for new designs, volume production, not recommended for new designs, end of life, and then the final obsolete. And then we transitioned into talking about some of the environmental initiatives that are tagged, that components are tagged with. I mean, we've all heard of RoHS, but there's also REACH that impacts some designers, as well as conflict minerals.
Sure.
And such. So that was, I can continue, or if you have any other questions on that so far, let me know.
I think that's a great overview. The questions I would have are, did you delve into and are these topics relevant to how hard it is to get parts right now? And I think it ties right into the systems now that we have in place to go find those parts. We enter data. I'm getting that we enter data, and we have search capability, and knowing knowing the pieces of the puzzle as far as part numbers is really important. Talk to me more, and talk to our audience more about that.
Yeah, I'll just continue through the agenda because I've only went through some of it. We do get to all of that in the presentation. We talk about, adding part choices to your components and such. But, we also introduced what I thought was, I don't know, I thought it was the more intriguing part of the presentation, at least from producing it. We talked about design architecture and the trade-offs, whether you use a board with a lot of daughter board connectors, or DRAM module chips, that type of modularity and the trade-off that has on sourcing. We went down a layer of abstraction. And we gave an example of where you can use an integrated, 8-pin SOP switch, or you could design that same switch for this specific application using a discrete implementation with about 5 resistors and 2 transistors. And as it turned out, that IC is in short supply and about $5 a part, even in quantity. And of course, the discrete implementation was pennies. So we talked about how design architecture can impact sourcing.
So being able to manipulate the variance to come up with solutions that are procurable is the deal, right?
Exactly. I mean, we're all familiar with the idea of using an alternate part, but what about an alternate implementation? And our tool set has been adapted to that for at least a decade, probably even more, with our reusable design blocks. So you can actually, you can proactively anticipate what kind of issues you're going to have. And indeed, that's, what we went into. We had a section on early planning for critical blocks and components.
Some of the design challenges that we face as people who lay out boards and are fed schematics and need to find these parts. Sometimes there's a strategy out there of actually designing in multiple footprints to the circuit, which can get real clumsy, and you end up with a lot of copper patterns or combining copper patterns. Do you feel that that's a good strategy, or is it a necessary strategy? In fact, what that would mean from what I hear is that we have maybe 3 patterns that we've designed into as alternates, and but even those 3 alternates may need, you wouldn't put them in without several sources. You stack the requirements. What do you think about that?
Well, I mean, it depends on the application. I mean, the idea of having, multiple footprints may work very well. I gave 2 examples in the talk, one being a beeper, one that had it was the pins were in line with the sound port, and the alternative part were rotated by 90 degrees, and we just built in a footprint that would accommodate either one. Now, there wasn't any kind of EMI issues or crosstalk issues. It wasn't a critical situation. Exactly, but there's that trade-off between how you might impact the performance of your design and the idea of being able to get your design done. And, a really fundamental point that I made is, you got a choice. You can either not produce your board, and again, we gave an example of a crystal, an SMT mounted crystal, or you can take the time or pay the cost to solder in an available through-hole crystal in its place. So these are just the kinds of things that we have to, design, or think about now. And it's the idea of, maybe having some just in case designs ready to deploy if that's the way you need to go.
Absolutely. And we always, it makes me think as a designer, we always need to be conscious about the technology. It'd be nice to have alternates, even if it's an alternate shaped SMT footprint that's interchangeable with a different style SMT footprint. When you mentioned that, if we have to punt and the only available part is a through hole part, so we design a pattern for that, we have to know and really communicate with our assembly stakeholders that if we go that pinned route, that's going to cause a whole different manufacturing process change, and everybody's got to be aware of that and how to address it down the line, right?
Yeah, absolutely. And I know with our capability that, we allow, commenting at the schematic board level, there's a lot of collaboration and capabilities. Like when we define these what we call variants, which are a variation of a design, A simple example being, say you have a processor board that gives you a choice of either 4 meg or 8 meg, or I guess I should say 4 gig and 8 gig memory. You can make that choice at assembly time. The BOM automatically updates and reflects that. Any documentation you've designed automatically reflects that. So what's forwarded to the manufacturer is exactly what they need to build, and also exactly what parts they need to procure.
Right. From a volume standpoint, and choosing parts for volume, again, the the challenges out there right now are significant. Um, we're relying on the relying on the system now to tell us what's available through multiple sources. Um, is there any human interaction at that point, or is it just the software going out to the web and collecting data from the web? Is there any value in calling up on the phone personal sources that can say, "Oh, but I have a secret source"? Do we even consider that, or is that way out of the realm of the
I
of the
think you
process or
can
workflow?
consider it. There's no doubt. It's just like when they talk about travel and hotel rooms. There's always hotel rooms available. They always
Right.
allocate a little bit. I would maintain, though I can't say I have direct experience, that there's probably always some parts available. So let me answer your question in a couple of parts here quickly. The key is to be able to have early warning that you have a problem. You may have
Good point.
already selected a part, you're looking good, and you find out mid-cycle, just like airline tickets, you can't get those parts. And so, again, what we showed in this talk is how our products are instrumented, if you will. The awareness of what supply chain issues are intrinsic to the product. When you're placing components from your library, you get a flag if you have an issue, a stock issue, an end of life. When you're looking at the component parameters and you select that on the schematic, you're flagged on that. It's all throughout the product, because that's an important aspect to have that early warning. Now, if you're really in a bind, and especially if you have some decent volume. I mean, one of the dynamics that I've seen in this last couple of years is if you're a small person, small company, buying maybe thousands of parts, you're
Hmm.
probably going to get bumped. When you buy parts, it's not like at the meat counter where you pull a ticket and you're guaranteed to be called at that number. You will
Oh,
be
I thought I
bumped.
thought I thought I was good at metaphors and analogies. That was a good one.
Yeah, I mean well, yeah, I've been bumped, so I'm really sensitive towards this.
Yeah,
But
absolutely.
so that's when the call could be important. That's when the
Yes.
relationship with that component rep is important. Sometimes companies are trying to get a product out the door that can mean a lot and can even mean more business for that semiconductor company. And so making that case and seeing if you can get an earlier position in the line could
Mhm.
be a really good thing. I mean, the personal relationships can come in very handy. Having said that, I find when I do my design and such that I am relying on that instant connectivity to this component cloud. It's just quite amazing, and it's just
Right.
is really something how quick things can change. I know I've given
Yes.
demonstrations before. I prepare for it and everything. Everything looks good, and on the demonstration day, I've got parts that are out of stock. It's just the way it
It's
works.
inevitable. Yeah,
Yeah.
yeah, it is. But the good news is you're using the tool and you're using technology and you're using data to make intelligent decisions. But the first thing I think about, being old school, I got this gray stuff going on here, is the are we making the workflow, a digital workflow, uh, a stakeholder in finding availability of parts, which in a sense is kind of replacing the personal stakeholder, the supplier management group or the purchasing group or the people that service and provide the components. I think in summary, what we just discussed is, maybe we need a little of both, right? We can't forget that human stakeholder out there that really is pulling the levers. Would you agree, or
Yeah,
a
yeah.
different take?
I think one of the things that's going on in many aspects of design is a lot of awareness is being required to be moved earlier into the process. So most designers don't usually worry about sourcing components, but you have an opportunity to help your companies if you are aware of that. And just to use
Yes.
another metaphor from, the national security aspect, is if you see something, say something. Even though it's not your job to order parts, you know what? If your company can't ship its products, that's not good for anybody, down to the
Yeah.
person that cleans the offices in the evening.
Yeah.
So
Point well
there's
made.
an and the other thing is that, imagine trying to do design work without the internet today. I mean, you can do it. We did that before. I used to have to sort of beg for data books. Those things were expensive. But imagine trying to design now. So what happens as more people adopt this digital infrastructure of supply chain information, you're just going to be at a disadvantage. And we've seen many areas in our technical space where that dynamic is played out.
Yeah, because it's instantaneous now. We have instant access
Yeah.
to knowledge. I was going to make a silly comment about, because it made me think about back in the 80s or the 70s of, if we had had the internet then, how great that would have been to be able to use it to order more tape to tape up our artwork.
Right, exactly.
We had no idea this was coming. We had no idea
Bishop
this
Graphics
automation.
comes to mind.
Yeah,
Yeah,
yes.
Bishop
Let's name
Graphics.
drop a little bit. and we did it back at 10-1 or whatever.
Yeah.
The old days. Yeah, so it was really amazing. One thing, we signed off today off the show floor, and we I didn't have a chance, or it didn't come to mind at the time how cool it is. I think I'm going to write something about this. How we've gotten to the point where now we can use Altium tools, and we can bring in step files, and we can create these wonderful designs that we hit a button and we're in 3D mode, and we can rotate these parts around before any parts are ever assembled or cut, or any materials ever ordered. We have a design, and we're flagged if some of the components in the assembly are not available. We have all this data. But what was really cool on the show floor is to walk through all the processes, and I had an aha striking moment, that because we talked to an assembly supplier, and we get down to the end of their assembly processes, and what do they have at the end of their assembly process after it's gone through pick and place, after it's gone through the reflow ovens, it's been stenciled and everything. But we get to the end, and we get to an inspection point, and we get turned on to 4D inspection. They're calling it, where they're snapping pictures on top and around, and they create a 3D image. And this is a pictorial 3D image that's been created photographically of the actual parts that have been created by all the processes. And so it's almost like we could put this one image up of the Altium 3D view of what is to come, and the end view of what was actually made, and I think they look really similar, and it's just, that's amazing to me. I think we live in a great age.
Yeah, the optical inspection in general, they can read component values in some cases and look at solder joint quality, and thankfully that's come along as technology has escalated as far as density, speeds, etc.
Absolutely. So back to ordering real quick, and then I know you're busy. Talking mostly about components, but availability issues at the previous level, at the bare board level. Did your talk happen to touch on availability of materials? Because this can be an issue out there too, or is that part two, or a previous part? A or B?
Well, I think we didn't touch on that, and I'm assuming that by materials you're talking about bare board materials.
Yeah,
Uh,
laminates, for instance.
yeah, exactly. Because I was talking to a major fabricator based in the Chicago area, and in the conversation, I said, "Hey, by the way, you having any issues with these supply chains? What are you seeing from your customers?" And they say, well, we're seeing a lot of board revisions because people are redesigning around alternative components. That's understandable. But the thing that
Right.
she said that I never really thought about is she says, we had this pre-preg that we could get in 2 days. It's a specialized pre-preg. Now we can't get it for 6 months. I mean, that's really a bummer when you can't even get your board fabricated.
Yeah, just throwing it out there, floating that balloon that maybe could the same process, the same alerts come up with for stack up. When engineers and designers are creating their stack ups, that gets back to stakeholder awareness. Who are the people that really tell us who
Right.
can build this board and what is available? That may be another story for another time, another chapter in solving this problem of awareness. Maybe in the future that can be worked on as
That's a
stack
great
ups are
idea.
created.
I mean, it's the same thing. You need a certain material and you need to know whether you can get it or not. I mean, fortunately, in our existing solution, a lot of the mechanical parts that you would use, whether it's battery brackets, screws, standoffs, things like that, those can all be instantiated in your design and made part of that awareness. And, that's the reality about this whole electronics gig is, and you got to have all passengers on the plane before that thing can leave. And you can have you can be missing an insulated washer you can't get, and you can't ship your product, or you have to do something crazy. So it's all important.
Yeah. I think there's many of our viewers online here who can relate to those stories. I know I can, and it's a challenge out there, but we're here to solve them. And
Yeah, exactly.
very very interesting talking to you. I'm definitely going to watch your presentation. We've captured them here, and we can
Nice.
call them up at will. So that's wonderful. Vince, it's been a pleasure catching up with you and meeting you. We haven't met before, so I really appreciate the opportunity and that you've leaned forward and you're presenting valuable information.
Well, thanks a lot. Nice meeting you too.
Yeah, great. Well, I think it's a good time to tell everybody good evening. I don't know if we'll come back in tonight, this evening or not. Here it's what is it, about 5 or going on close to 5 Pacific time. So for any of our viewers out there, we'll probably not be back this evening. Yeah, and we'll be back, I have a feeling. What's that? We will be back today, I'm told. Okay, so hang out. I'm glad we'll be back today. I love talking to you. And Vince, thanks. It's been a pleasure. Thanks so much. And to our Altium Live Connect 2022 audience, stay tuned.
Okay.
We've got some
Take care,
sessions
Kelly.
coming up. Yeah, thank you very much, Vince. Real
Have a
quick,
good one.
Yeah, thank you. We've got a couple sessions, a few sessions coming up at 4:15. Is that right? They may have already started. We've got high power subject matter. We've got what is target Z, and how does that affect things? And we've got a microfab platform subject matter that you'll like to tune into, and footprint mistakes and how to avoid them. These are all very relevant topics. And again, I'm Kelly Dack for AltiumLive Connect 2022, and we'll see you next time.
Well, gotta act fast. Sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. Entertainment. This event will be hip. We're in partnership with the folks from the IPC. Stakeholders unite and we'll feel alright. Digging multi-show synergy. So let's all connect. Come on, people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine. Check us out. Virtual attendance. Yeah.
So we have to create a thermal profile to ensure that we get the flux to the proper temperatures that the flux manufacturers specify. And there's a certain temperature it has to get to, so a minimum temperature and a maximum temperature.
And these are external to the board. These are external temperatures, right? Because obviously
Correct.
inside
Well,
the board,
right.
it's not being fluxed or soldered.
So the industry standard is we're going to measure that as the topside board temperature prior to getting into the wave. So we have to get it to a specified topside board temperature prior to the wave at a certain heating ramp rate, not to exceed 2 degrees C per second typically.
And we see the machines are movable. This angle is adjustable.
It is adjustable. It is adjustable, but we design our process at a 6-degree angle. That gives us the optimum soldering results in our equipment, but we do offer it that we can change it from 5 to 7. So depending on the process, you may be able to fine tune it, maybe at a 5-degree angle, may give you slightly better results, but typically what I've seen is 6 degrees is what majority of our customers run their conveyor at.
Let's see what's the next step in the process here. Where does it move on to? We've got a nice diagram.
Yep. So after we preheat, these are preheat modules. So that's activating the flux and thermally conditioning the board. Then it'll go into the solder waves. And I can, so the graphic, when it's on, it'll show the solder wave actually pumping. So let me turn that on for you so you can see that. Okay. So as the board travels, it goes to the preheat, and then it's going to go across the wave and apply molten solder to the bottom of the board. And then wherever the copper is exposed is where the solder will wet. And so we apply it from the bottom, and then through capillary action, it's going to wet up the barrel, up the lead, and then create the fillet on the top. That's what we call capillary action or wicking.
Right. So as far as design is concerned, it's very important for designers who are dealing with through-hole components to understand this, that there must be enough room in the maximum material condition size of that hole and the maximum material condition size of the lead to still allow room for that capillary action for the solder to flow up. And are you trying to form, well, the IPC standards or specifications are the ones that dictate what the solder joint should look like on the bottom and how the solder is viewed on the top. It doesn't necessarily have to be a perfect fillet on top.
Right. So especially with lead free, it has, we're looking at hole fill, percentage of that barrel filled. And depending on the class of soldering, class 2, I think it's 75% on the ground pins, 100% on the signal pins. Class 3 is 100% on both.
There must be challenges. Some designs might be challenges. What if you have a heavy copper board that has thin copper on the outers for etchability, but they're carrying power, and which could connect to things that are going to sink the heat out. Explain what you do for that. Is this profiled? Is the term profiled, heat profile, used in wave solder?
Yes. Yes, it is. So you can. So you have to make sure you heat to the maximum that the flux will survive, the maximum specs, and then the rest of the heat you need to get the inner copper planes hot. You have to do with contact in the solder, and we call that, the contact time or the dwell time, and that helps transfer the heat by induction into the copper. So then the solder will wet. So in design, it's very important in those inner planes that you create thermal relief on how the barrels are tied to those copper planes. You don't want a solid connect on all those planes, or you can't get it soldered to come to the top.
Okay, you heard it. This is kind of a, sometimes we think of it as diametrically opposed. This is where design for manufacturability and design for performance, electrical performance, they seem to butt heads. A lot of the design engineers, PCB layout folks, you know, they're directed to make these direct connections for performance reasons, but they also need to understand that a board that could electrically perform well, in order for it to perform at all, has to have a viable solder joint, right? So listen to the stakeholders. If there's a way to be able to add thermal relief, especially in the inner layers, and still carry your current, we need to make every effort to do that, right?
Correct.
Because nothing's worse than a cold solder joint. You've gone through your whole process, and a rework is required, which stresses the board even more.
Or may not even be able to be reworked because the component itself restricts access